Hi guys, welcome to another new video from Bioorganic Hub. So in this video we will also discuss, as like the same video the previous, that we will discuss a short questions for 2 marks in chemical science. So in this questions is about Birch reactions, which is very important for chemical science questions. So the question was like this: it is a COOH group, that is electron withdrawing group, you can understand, and you have a unsaturation like a alkyne group. So what will be the reaction product? That was the reaction conditions, and this was the 4 options. Now we will go through the questions. So this is, you can understand the typical reagent when you will get in your exam paper. The sodium liquid chemistry is obviously, you can be sure that this is for Birch reduction. And when you obviously have an aromatic system, obviously it will give results in the Birch reduction. So what happens for Birch reduction? If you have, we will discuss the mechanism in the next slide. If you have an aromatic system, it will just go the benzoquinone type of compound. Now if you have this type of system with an electron donating group, so in this case you have to remember the 2 mechanism. It differs actually in electron donating group substitutions and electron withdrawing group substitution, as it's going here that COOH electron withdrawing group and OMe here electron donating group. So for OMe you will end up a product like this, and for COOH you will end up a product like this. So that the 2 main difference for these questions, for this type of reaction. And another important thing, that if you have an alkene system and you will allow it to sodium liquid chemistry like Birch reduction, you will end up in the trans product. Okay, but why and this is the trans product, and if you have the hydrogen Lindlar catalyst, it will end up in the cis product. So hydrogen Lindlar catalyst, what happens? The activated hydrogen actually going to be attached on the alkyne system from the same side. That's why it creates a cis product. But if you have Lindlar catalyst, it forms such a transition state which attached it hydrogen from 2 different sides. That's why it goes to trans. So this is one form. On Birch reduction, alkyne will give the trans product, and electron withdrawing group will give this type of compound where the pi bond is actually away from the carbon holding the electron withdrawing group. You have to remember like this: the pi bond is away from the carbon what holds the electron withdrawing group, and for this case electron donating group, it contains the pi bond on that carbon which holds the electron donating group. This is the procedure to remember the power reactions. So this is the mechanism you can understand. If you have electron withdrawing group, this carbon atom is actually some extent del positive, because this is the electron withdrawing group, so electron can attack here. So this is happens by a single electron transfer mechanism, ACT, single electron transfer mechanism, because sodium liquid chemistry will form sodium dot means Na minus means 1 electron, not a 2 electron pair will not be attacked. So here is single electron transfer mechanism. That's why you have to remember this is single electron transfer mechanism. So that's why it will transfer only 1 electron per step. So it is from this type of 1 electron system here, because this was the electron deficient carbon atom. You have to elucidate the mechanism, you have to just remember one thing: for the electron withdrawing group, this is the carbon where electron will attack. Now another electron will attack at the same carbon. This is just a negative charge will happen here. So this negative charge will take up a hydrogen from this tertiary butoxide solvent, and this will end up this type of compound. On addition of another type of electron, this will form this type of compound. This is the resonance. This will go on resonance here, this will go attach here, and this will go like this. So this will end up in a resonance system, and this will create this type of compound where you have to remember policy is that the 2 pi bond is away from the carbon atom which actually holds the electron withdrawing group. Now for electron donating group, you cannot attack the electron here because you have already electron donating property in that carbon. That's why it will attack here, and by the same mechanism it will make a single electron here, and then in the next step another electron here. So now it will end up this type of compound. Okay, so where the 2 pi bond is actually near the carbon atom which holds the electron donating group. So on getting this type of informations, we can now be able to solve this question. So what will be the answer? We can try that. It is a COOH, so this is the electron withdrawing group, isn't it? This is the electron withdrawing group. So we know for electron withdrawing group what will be the product. Electron withdrawing group, the pi bond will be away from the carbon atom which holds the electron withdrawing group. So the carbon atom is pi bond is away from that carbon atom which holds the electron withdrawing group. This carbon also, this is also the same, but this not. So this is, you can cancel out, this you can cancel out. So along these two, we have to find out what is the product from this moiety of the product of the reactant. So this is alkyne, and you have a sodium liquid NH3, so it will form a trans compound, not cis compound. You have to remember cis will happen when hydrogen, linear catalyst will go and attach the hydrogen from the same side, but this will be trans compound. So this has given the cis, so this will not happen. So you can just cancel it out. So only this is the answer. So this was the answer. Okay, so this is very easy questions. You can figure it out by just knowing the simple two mechanism for the okay, that's all for for this reactions, and thank you for watching. That's all.